what do you get when you integrate 1 over x dx? Right, so to answer the questions, we have to go back to the differentiation of the logarithmic functions, because after all, integration is the reversed actions of the differentiation, right? So if you were to recall that when we differentiate ln x, you get 1 over x. So what we're going to do now is that we're going to add the integral sign to both sides, and then multiply by dx, multiply dx to both sides, and then just shift the position because I'm interested in integrations of 1 over x dx. Now, so recall that differentiation and integrations, they're actually the reverse of each other. So therefore, when you differentiate ln x, the answer you get and you integrate it, what you get is just your ln x only. Okay, and of course this is an indefinite integral, so we need to add an arbitrary constant c. So when you integrate 1 over x, when you have integrations of 1 over x dx, the answer you get is ln x plus c. So how about when you want to integrate 1 over ax plus b, let's say, all right, what would the answer be? So we're going to carry out the same steps as what we have carried out for the integrations of 1 over x. We start off with the differentiation. So if you were to recall, when we differentiate ln bracket ax plus b, right, the answer we get is a over ax plus b, right? So we're going to add the integration sign to both sides, and then we're going to multiply both sides with dx. Okay, right. Similarly, what we're going to do is we're going to shift the position. Whatever on the right, put it on the right. Whatever on the right, put it on the left. Whatever on the left, put it on the right. Okay, and integration and differentiations, they are reverse of each other, so cancel off. So what you ended up with is just ln bracket ax plus b. Now on the left hand side, a is a constant. Can I just take it out? Alright, I'm going to divide both sides by a. Right, but ln bracket ax plus b over a, you can actually write it as 1 over a, then ln bracket ax plus b. Alright, so recall that this is an indefinite integral, so therefore you need to add the arbitrary constant c. Okay, so this is what you get when you integrate 1 over x dx, or when you integrate 1 over ax plus b dx. Try to do some examples. So let's write down the rules that we found earlier on. So integrations of 1 over x dx give us ln x plus c, and integrations of 1 over ax plus b dx will give us 1 over a ln ax plus b, and then with the constant c. Right, so let's try to do some questions. Let's say if you're asked to integrate 1 over 2x dx. Alright, so what do I do? So we can actually simplify your 1 over 2x as 1 over 2 times 1 over x. Right, and then your half is actually a constant. You can just move it out from your integral, and then this one here you can just apply rule directly, so that will give you half ln x as a constant c. Okay, so this is relatively easy. Now Let's try another example. If I have 1 over x squared dx, right? So can I apply the rule? So the question is that, can I apply the rule? Okay, the answer is no. All right. If you look at the rule carefully, it's 1 over x to the power 1. It must be x to the power 1. Okay, so what you have here is actually power 2. So in this question here, you cannot apply the rule. So in this question here, then how do you integrate? This one, you have to convert it into your negative index. And then you will remember, we learned integrations of x to the power n, simple integrations, right, where you just take the power plus 1, then divide by the new power plus a constant c. So here will be just x to the power negative 2 plus 1, then divide by negative 1, right, gives you x to the power negative 1 over negative 1. You can put the negative 1. When you divide by negative 1, it's basically just negative x to the power negative 1, then you convert your x to the power negative 1 into positive index is just 1 over x to the power 1. Okay, gives you negative 1 over x plus an arbitrary constant c. Okay, so if you have 1 over x squared or 1 over x cubed, 1 over x to the power 4, no, you cannot apply the rule. The rule is strictly for 1 over x to the power 1 only. It's actually a linear factor. It's meant for linear factor. Integrations of linear factor. Alright, let's try another example. How about integrations of 1 over 2 minus 3x dx? Alright, so let's write down the rules that we have learned. If you need to integrate 1 over a linear factor, ax plus b is a linear factor. This one must be a linear factor. Okay, so what we get is a ln bracket ax plus b multiplied by 1 over a plus a constant c. Yeah. All right, so let's check whether this denominator, is it a linear factor? Okay, to be a linear factor, the highest power must be 1. And yeah, correct. X to the power 1. So this is a linear factor. So we can apply this rule here. Right. So that will give us, what's the first step? The first step is I need a ln there, followed by your linear factor, which is 2 minus 3x. And then I need to multiply with 1 over a. And where exactly is a? A is actually, how do I get this a? This a is when I differentiate my linear factor. When you differentiate the linear factor, you get an a, right? So I need to multiply with differentiation of my linear factor. Alright, so if you look at the linear factor, when you differentiate 2, you get 0. Differentiate negative 3x, you get negative 3. Alright, so 1 over negative 3, you can write it as negative 1/3. Okay, so this is what you get. Try to integrate something that is more complicated. Okay, right, so for all integrations, before we jump into applying the rules, the basic rule is to always try to simplify the expressions as given to you. You know, when I say simplify means, what do I mean by simplify? Means if you're given like something to the power of 2, right? Then you would expand it first, okay, to get a simpler terms first before you actually apply the integration rules. So if you have like um 1 over like ax to the power n, and then you should simplify it as 1 over is a constant, so pull out your constant and then convert your 1 over x to the power n to a negative power, okay, before you apply the rule. So likewise also, if you have integrations of square root something dx, then you should simplify it to bracket ax plus b to the power half dx before you apply the rules. This is what I mean by you should simplify your expressions to make it simpler, all right, to make it simpler before you apply the rule. So if you look at this question here, all right, we can simplify it further. What you're given is just one algebraic fraction. We can actually separate them into two partial fractions. Into two fractions. Okay, into two fractions like that. Right, you can only do that when there's only one term at the denominator. All right, how is it that you can do that? You just recall that I'm going to do a reverse action for reverse action for you. If you have 3/4 plus 5/4, right? If you were to add them, you get this, right? Right, so but then if this is what you're given, you can actually break it up into 3/4 plus 5/4, right? So if you can do that for numbers, you can also do that for algebra. Okay, right, but I need to caution, I need to remind you, you can only do that in this situation. If you have like 4 plus, if you have 4 over 3 plus 5, surely this is not equals to 4 over 3 plus 4 over 5, okay? Right, please take note. So things that you cannot do to numbers, you can't do it to algebra also. Okay, so after you simplify already, okay, we can still simplify further, as in like 2x divided by x will give you 2, right? And then you can just integrate 2 dx minus integrate 3 over x dx. So integrate 2 by now you should know is 2x lah. We have mentioned it so many times already. Then for this you can just pull out your 3. And so this is a linear factor, x to the power 1 is a linear factor. So for that, integrations of 1 over linear factor will be just ln x and then plus a arbitrary constancy. After learning how to integrate 1 over x or 1 over ax plus b, let's put our knowledge into practice. So I'm going to write down the formula again for you. So integrations of 1 over x dx, you will get ln x then plus arbitrary constancy. The integrations of 1 over ax plus b dx, you would get 1 over a and then ln bracket ax plus b then plus an arbitrary constancy. I'm going to bring our knowledge to the next step. The questions that we need to ask ourselves is, what happens if I'm given questions in this form? Right, how do I integrate it? What is the answer? So what does this algebraic fractions remind you of? Which chapter can you recall that you have done something like that? Yes, in the chapters polynomials, right, where we learn how to decompose in algebraic fractions into two partial fractions. So for integrations of 1 over ax plus b dx, this one here, this is very closely linked to the concepts of partial fractions. Okay, so usually in the exam, usually in the O-level exams or in the school exams, right, part A will usually ask you to express an algebraic fractions into two partial fractions, and then from there you would apply this rule here, right, to integrate 1 over ax plus b. Right, so how do we go about doing it? So the first step is that I need to decompose this into two partial fractions. Right, so if you have forgotten the rules, it's good. Now is a good opportunity for you to revise. Now, if you look at the denominator, it comprises of two linear factors. So for if the denominators are linear factors, it's very easy, right? You just let it be. Can be decomposed into a constant over the first linear, plus and b over the second linear, right? And then if you were to recall, we can combine them into one single fraction again, right? And then you just compare your numerator on the right with the numerator on the left. Okay, so what we have here will be a bracket x plus 1 plus b bracket x minus 1 equals to 1. Right, so the important thing here is to find the unknown a and b. So we're going to use substitution method. So I'm just going to let substitute x to be 1, because if x is 1 here, then I'll eliminate my b, because 1 minus 1 is 0, 0 times b will give me 0. So if that happens, I can easily find the values of a, which is half. Right, then to eliminate a, right, I just let x equals to negative 1, so a will be gone. So b will be negative 2, b will be, not yet. So we just substitute x to be negative 1, so b times negative 1 gives you 1, so b will be negative half. Okay, so after finding all this, finding the values for a and b, we can put back in the partial fractions. So the partial fractions will be half divided by x minus 1 plus negative half divided by x plus 1. Okay, so we're going to use a trick here. The trick here is actually quite easy. Just look at this. The denominator, it's a number 2, so just multiply by 2 at the numerator, 2 at the denominator. Likewise for the second fractions. So half times 2 will gives you 1. And then negative half times 2 is negative 1. So plus times negative gives you negative. So become negative 1 over 2 bracket x plus 1. So we have successfully expressed the huge algebraic fraction into two partial fractions. Right, then how do I continue? So what we are integrating is actually 1 over 2 bracket x minus 1 minus 1 over 2 bracket x minus 1 dx. Okay, so we can separate it into integrations of these two partial fractions, right? Okay, and if you look at the the denominators, they are both linear factor. So integrations of linear factor, right? Let's write down the formula somewhere. Integrations of linear factor gives you 1 over a, then ln bracket ax plus b, okay, plus a constant c. Right, so the first step is that you can actually take out the half because it's a constant. Okay, right, so this one will give us ln x minus 1, then times 1 over times your 1 over a. A is when you differentiate x minus 1. So you differentiate x minus 1, you get 1. So times 1 over 1. So for the other one is you get ln x plus 1 Okay, also times 1 over 1, because when you differentiate x plus 1, you get 1. So you simplified it, you have half ln bracket x minus 1 minus half ln bracket x plus 1, and the plus a constant c. Not to worry, let's do another example. Right, integrations of 1 over, okay, maybe we don't put 1, maybe integrations of 3 over 2x minus 1 and x plus 1, let's say. Okay, right. So the first step is that we need to express our algebraic fractions into partial fractions. So if you look at the denominator, they are both linear. So we're going to let 3 over 2x minus 1, x plus 1, let it equals to a over 2x minus 1 plus b over x plus 1. Okay, then the next step is combine them into one huge fraction. Okay, then we combine your numerator on the right with the numerator on the left. So we will have a of x plus 1 plus b of 2x minus 1 equals to 3. Okay, substitution method, I'm going to let x equals to negative 1, so I eliminate my a. Right, so I found the values of b. Just going to let x equals to 0 to find the values of a. So I found b to be negative 1, so I can just put the negative 1 there. So I would have a plus 1 equals to 3. So a will be 3 minus 1, 2. Good. So I found all my constants. So this one will be equals to 2 over 2x minus 1. Okay. Plus your b is negative 1 over x plus 1 and dx. Right. So this positive and negative will give you negative. So you would get this. Okay, right. So 2 is we have 2 here, which is a constant. You can just take it out. All right, so now we can apply the rule. Okay, we can apply the rule because all these are linear factor. Right, so what we get is leave the 2 alone there. Don't worry about the 2. So to integrate this, you will have ln bracket 2x minus 1, right? Then times 1 over the differentiation of your 2x minus 1. You differentiate 2x minus 1, what do you get? You get 2. So for this will be just ln bracket x plus 1 times 1 over differentiate x plus 1 to get 1. Okay, so you simplified it, or you will have 2 times half. Right, you can put all the numbers together. So there's a 2 here, and then there's a half here. So 2 times half will be 1. So you have ln 2x minus 1 minus ln bracket x plus 1. Because ln bracket x plus 1 times 1 will give you ln bracket x plus 1. But if you want to simplify it further, which I don't think is necessary, but if you want to simplify it further, right, recall that ln a minus ln b gives you ln bracket a over b. So actually, if you want to simplify it further, this one can be equals to ln bracket 2x minus 1 divided by x plus 1, and then plus a constant c. Give up if you can't, if you don't get the answer in the first or second try. Look through the video again and try it one more time, and I'm very sure that you should be able to do it.